Hello, everyone. Thank you very much for joining us today. It is a real pleasure for us to welcome you to this fourth webinar organized by the Broadwin Project. Today, we will focus on the challenge and opportunities in the development of novel products. Before to start with our two speakers, I would like to invite Dr. Aitunga Kibar, who is coordinating the project, to give us an overview about the project. So, Aitunga, please, the floor is yours.
Thank you very much, Irma. I'm going to share my screen. Okay, can you see it?
Yes.
Okay. Hello, everyone. Welcome and thank you very much for joining us today. My name is Aitunga Kibar. In the next few minutes, I would like to briefly introduce our project, Protivin. Protivin is a 3-year Horizon Europe twinning project. It aims to enhance the scientific and technological excellence in the plant protein research, particularly in TÜBİTAK Turkey. We are doing this through our collaboration with the leading European partners, as you can see on the map of the project. The protein diversification concept, this is directly lies at the core or the heart of the Protivin project. We are focusing on improving our understanding of plant protein functionality, digestibility, and interactions with the gut microbiota. Our approach combines extraction and processing techniques with omics-based tools. Our main goal is supporting the development of nutritious, sustainable, and consumer-acceptable plant-based foods. Protivin scientific focus areas are structured around 2 main pillars. The first pillar is focusing on protein isolation, fractionation, and modification. This includes the valorization, also the byproducts. The second pillar is addressing nutritional quality, mainly the digestibility, bioactive peptides, and also the gut health and microbiota interactions. And all of these activities contribute a broader ecosystem building strategy. And in this way, we are trying to link the research excellence with training, visibility, and long-term impact of the project. In order to achieve these goals as Protivin project, we are implementing a wide range of capacity building activities also. And these activities are on-site trainings, technical and expert visits, mentoring activities, summer schools, webinars, and some workshops. All of these activities are designed to promote the hands-on learning, knowledge exchange, and also long-lasting collaboration across the academia, research, and the industry. I would also like to briefly highlight another project. It is very complementing with Protivin activities. It's Excel4Pro, another Horizon Europe project and coordinated by TÜBİTAK. It is aimed also strengthening the innovation capacity and collaboration between Turkey, Greece, and Ukraine, particularly in the field of plant protein-based novel foods. So as a joint effort, this project also focusing on building strong innovation ecosystem by connecting research, industry, and entrepreneurship. So it is fully aligned with the objectives of the Protivin project. Okay, today's session is mainly focusing on the challenges and the opportunities in the development of novel food products containing alternative proteins, and it's including the aspects related to supply chain, nutrition, and regulatory frameworks. On this occasion, I would like to thank today's speakers for sharing their time, experience, and valuable insights with us. And before move on, I would like to kindly invite you to follow the Protivin and Excel4Pro project websites, also our LinkedIn page, if you want to stay informed about our upcoming webinars, training activities, and other project events. And thank you very much for joining us today. I'm now pleased to hand over the moderation to Irma, and she will guide us through the rest of the session. Thank you, Irma.
Okay, thank you so much, Aitunga. So now we are going to introduce our first speaker. So thank you, Dorothée. Our first speaker is the Professor Dorothée Goffin from the University of Liège. She's the director of the Smart Gastronomy Lab, and she's also director of the Master's Studies in Food Innovation and Design. She has a background as an engineer in chemistry and bioindustries, and also a PhD in agricultural science. She has developed a lot of expertise in creativity and innovation management. Her interdisciplinary research focus on food innovation, combining food science, consumer behavior, creativity, and advanced technologies like, for example, the 3D food branding. So, without further ado, I would like to thank Dorothy again for being here with us, and I will give you the floor for your talk, which is based on from novel ingredients to market impact, the art of designing disruptive food products. So, please, Dorothy, the floor is yours.
So thank you very much. Can you see my screen? Is it okay?
Yes, it is okay.
Okay, so thank you. So I will try to fit inside the 20 minutes. It will be difficult, but I will try my best because it's a long journey to develop a new food product, and you will see the different methodology we have to use to develop these new kinds of food products. The first thing, it's working, yes. The first thing is to know why we want to innovate. Do you want to develop a product from a new type of healthy ingredients, for example? Do you want to change ingredients or the process we are using for the moment? Do we want to answer a new tendency of the market? Do we want to respond to a market need? Do you want to countertype a successful product already on the market? Or, for example, do you want to valorize a waste or a new co-product or things like that? We have to know why we want to innovate because before knowing how to go further with this kind of development. Second thing, formulation of a new product is a tricky things to do because we have to consider lots of different things: preservation conditions, regulation, the cost of the product, the practical characteristic, microbiological characteristic, organoleptic, because we want to sell that product and we want people to like it, nutritional characteristic, manufacturing process, and conditioning. The most tricky thing is that all those different parameters are also linked together. So if you change something, you change everything, and you have to do it again in the development of the product. When you see a label, you can see lots of information, the definition of the product, the ingredients that you want to choose, the labels, do we have some allergens, what are the distribution channels, ingredients origin. So lots of information that you have on the product. So today we are going to see four different methodology that will help us to go from the idea to the final product and to have really the final product concept. The first thing is the value proposition, is to know really what your product is going to give to the market and to the consumer that you want to address. The second methodology is the technological market analysis, because besides the business case that you want to develop, you really have to develop the technology of the product. After, we are going to see how we can draft the specification of the product. And finally, we'll see why it is very important to develop an MVP, what we call an MVP, so a minimum valuable product. So first, building up the value proposition of the product we want to develop. Why we want to do that? Because we already have lots of things inside the supermarket shelves, and we want to be different and we want to be better. So we have to see what we can propose to the consumer. The value proposition describes how a product or a service meets a specific need of a consumer segment by delivering clear benefits and solving specific problem of this consumer. So the first thing is that you have to identify this consumer to see their needs, the challenges, the expectation, and then define the elements of what you are offering that address this point, and check the consistency and adjust the product service if necessary. That's what we call these different steps. So first, the consumer segment, identification of who you want to address, and also identify other users that may interact with your consumer. And then after, you have to make the value map of your product, what your product give to the consumer, what gains it can have with this product, and what are the pain relievers also. How do your product and services help to address or alleviate specific consumer problems? After, you focus on the consumer profile, you see what this consumer needs, what are the gains they want, what are the pains, what they cannot do for the moment because they don't have the right product. And so the big deal is to fit this expectation of your consumer with what we can propose, so the value proposition of your new product. After having defined very well this value proposition, you have to see who is doing what already on the market. So for that, besides the economical market analysis, you should do a technological market analysis. That means that you have to see what the other person, other companies are doing already on the market with a comparable value proposition. For that, you can do two different things. The first thing is to do a technological literature review as scientists, but you can also do a technological segment market analysis directly by watching the products that are already on the market. When you do this technological market analysis, it allows you then after to do the technical specification that we will see just after. So technological literature review, the idea is really to see into the literature what is all about what you want to develop. For example, here you have the fermentation methods for vegetable juice. You are going to find all the different literature paper that talk about very closely or less closely to the problem you want to address. Then after, you can make some kind of comparative table, for example, on different types of products. Which type of products I have in the segment that I want to develop. For example, here you have protein-enriched products. We can have different types of protein drinks, protein bars, fortified yogurt, etc., etc. You will see in the literature which content of protein you have, what are the main protein source that you have for those type of products, what do you have beside those proteins, do we use additive, and what are the objectives for the consumer of this type of product, recovery, sport snacks, satiety, balanced breakfast, etc. The idea is really to make a full characterization of what we know from the literature. You also have to do a technological review of the process. For example, if you want to develop a new beverage, you have to know which type of process you will use. Are you going to use fermentation, like for kombuchas or kefir? Are you going to use flavoring, infusion, like iced teas? Are you going to use essential oil? Lots of different types of process and ways to develop the same type of product. Also, the choice of the ingredient is very important because you will have really different value proposition when you use different ingredients. For example, the choice of a sweetener ingredient, it's really tricky because you have lots of different types of sugar available, traditional, polyols, synthetic high-intensity sweeteners, natural high-intensity sweeteners, etc. And all the time you have different type of products, origin and process to produce them, advantages when you develop the product, and also limitation and typical application. When you know all of those information, you are able to choose the right one for the product that you want to develop to be in concordance also with your value proposition. Then after, you can, when you checked all the literature, you can go to the market and see what your concurrent are doing for the moment already on the market. So you conduct a technical analysis of the competitors and you see which type of ingredients, which type of technology they use, their differentiating factors, the origin of the ingredients, certification that they have, and also some trends that you have on the market. From that, you can determine your positioning and see what are your specific differentiating factors. What we do most of the time in the Smart Gastronomy Lab, we make some kind of supermarket safari, meaning that we check everything that is already on the market and see how it works. For example, here, alternative burgers, you have lots of different types of alternative burgers. You have simple plant-based analogs. You have mycoproteins like the corn. You have precision fermentation using engineering microorganism. You have cultivated meat also. So very different type of products, but for the same final product on the market. You also have different types of process to do those different type of burgers, like high moisture extrusion, fermentation, precision fermentation, or cultivation of meat cells. So when you analyze all that, you can have a good idea of what is already done and what you want to do in this new market. We did, actually, one of our PhD students did a big analysis of what is a burger on the market for the moment. So he tried hundreds of different types of burger, vegetal, meat burgers, fish burgers, and different types of alternative. And he tried to make a statistical analysis of the characteristics of these different burgers. And at this point, he put into light 4 different groups. A first group with high carbs and few proteins. Typically, it's the assembled burgers, vegetable-based patties, fish burgers, and things like that. The second group was the vegetarian burgers with texture protein, with distinguishable texture mimicking the meat. The fourth group was the 100 beef lean meat, and the last group was the burger made with fat meat, so more pork or fatty beef. So even if you have some specific categories on the market already identified, if you go further in the nutritional part, on the textural characteristic, you can identify different new types of groups inside a very known market. If you go now for comparing the process that you can use, for example, here a big issue, the preservation of a beverage, you have lots of different technology. For example, pasteurization, sterilization. And all the time you have a different principle, you have advantages and disadvantages. You have the typical shelf life that you can reach, the impact on the sensory profile, and also on the nutritional quality of the product. But you also have new types of processes, such as microfiltration, high pressure processing, pulse electrical field, and so on. Meaning that's difficult to choose which one is the best adapted to your product. For example, if you have, if you have some milk product, most of the times you have a premium fresh beverage. There you will use HPP or a pulse electric field, microfiltration. If you want to have products with a long shelf life at ambient temperature, you will use UHT, sterilization, aseptic packaging, for example. And if you want something more natural or artisanal with a nutritional function, then you will use more fermentation, natural acidification, mild pasteurization. So really, depending on what you want to propose to the consumer, you will choose the process. What you can also is to observe the information that your the product already show you on the label. For example, you have such phrases like produced using a slow fermentation process at low temperature. So it gives you a lot of information on how the product is produced. Sterilized at high temperature to ensure food safety while preserving taste and everything. So you have lots of information on the packaging already to see how you can produce the product and what are the main characteristics of the products already on the market. Here you can find lots of examples. You can also see who are the other trademark, where they are sold, and to link where they are sold with the quality of the product. Here you have an example with the kombuchas, so different kombuchas that are into conventional distributor or specialized distributors, and you see that you have a relation with the quality of the product. You can also challenge different technical characteristics of the product. Again, here we talk about kombuchas, fermented food, and we can compare and position the different products on the market through different characteristics. Here you have naturality at one point, and you also have the degree of processing of the product. And you can see then the products that are more processed and less natural, and products that are less processed and more natural. Meaning that after you have a new kombucha and you want to know where you want to go, if you want to go there to the quality, or if you want to go there to have less naturality but no process, or naturality with a kind of process. So really it's positioning, but positioning technically your product against the other product. Here another example for breakfast and liquid full breakfast solution, where we see the practicity, the fact that it's liquid or not, the nutritional equilibrium, and also the clean labeling. And you see your product and the different other products where they are positioned. You can also try to see what's the medium composition of all your competitors to see what's inside the product. And then you check if on your side, your product is better, for example, nutritionally, than the medium of all your competitors. You can also see what is which kind of packaging is used. Here you also, again, have kombuchas. And do you choose your packaging for technological choice, for practicity, for the price of the packaging, or maybe for marketing? Because you see, here you have the same type of product, but with very different packaging. Here it's more fun, it's for young people. Here it's more for saying that it's good for your health because it looks like more a treatment or something like that. So the choice of your packaging will say what is inside the product. When you have all this information...
Sorry to interrupt you, just to let you know that there are 3 minutes left.
Yes, okay. So I have to go very fast. So then after you have to define the product specification. And so the product specification, you will define all the quality of your product through the 5 dimensions of quality, meaning safety and security, satisfaction, service and convenience, sustainability, and also the health characteristic of your product. Why do you want to do that? It's because you want to translate the value proposition into technical specification that allows you to build up the specific product. So security, the idea is to ensure product safety. You have to check that the whole supply chain and the whole product cycle. You have to identify, quantify, manage, and control the security. You have a chemical, microbiological, and physical hazard that you have to manage. That's all you have to do to make a safe product. If you talk now about health, we know that there's a link between nutrition and health more and more. So you have to have an holistic approach on the composition of your product. So fat composition, glycemic index, matrix effect, the presence of synergic effects, biodisponibility of the nutrients. So you have to check everything about the health of your product. Here are some examples. So you can work on the nutritional composition, on the reduction or fortification of the product, the compliance with Nutri-Score or recommendations, on the serving sizes, the daily intake value, and the absence or presence of some additives, etc. You have some legal labeling, but you also have some optional labeling allowing you to make to show what are the specific nutrition claims that you want to address. As you should know, there's two types of claims that you can put on the packaging: nutritional claims, which relate to the beneficial nutritional properties of a food, meaning rich in something, or allegation like that. Or you have health claims that are directly linked to the effect on the health. So magnesium helps you to reduce fatigue and things like that. Integration of active compound, I will pass that because you can read it after in the PowerPoint. Satisfaction is very important to build up a product that people want to eat. So also you have to define the sensory profile that you want to develop. It has to be defined from the data of the market, the literature, the benchmarking, but also the intrinsic value that you want to propose. If you have a super product with superfood inside, but it's just disgusting, there's no point of selling this product. When you use a new healthy ingredient, you will see with Dorian just after with the purple bacteria, you have the health effect, but you still have to have something that it's good, because otherwise people are not going to take it. Here are some examples of ingredients and the potential sensory effect that you can have in the final product. Service, it's all about packaging, of how the format, the portion, is it ready to eat? Do you have to eat it? The time, the ease of use, the practical things that you can develop. It's mainly also linked to the packaging you are going to choose. Society is to know if you have some social ethics, the environmental part, sustainability of your product, the local engagement that you can bring, transparency, and also the shared value that you can propose with your product. I will not go into details, but you can check everything about those different parameters linked to society.
Thank
Last
you.
point.
I am sorry, but we are run out of the time, Dorothy. I don't know if you maybe want to.
Just 2 minutes, I have the
Sure.
MVP, and then after I have just the take-home message.
Perfect,
So
thank you.
the idea, the MVP, is to have something concrete that you can test directly on the market, so that you can see how you can make your product better. Key home message for food design. First one is to fit what your consumer needs with what you propose to your consumer with your value proposition. Second key home message, complexity of a food product. You have to check everything. Everything is linked, so difficult to do. So you have really to check all the parameters. Third key home message is that it's good to make an economical market analysis, but you also have to check the technological market analysis to see how you are going to build your product and what are the technological properties of your product to fit your value proposition. Fourth key home message is that you need to define the specification with the 5 dimensions of quality: meaning safety, satisfaction, health, sustainability, and services and convenience. And the last one, the importance of testing at all the points your product on the market to check that this product is aligned with the value proposition that you have. So thank you very much. Sorry to have.
Thank you, Dorothy. No worries. It's a really, really interesting talk. And yeah, we could spend hours talking about it, but you really did it sum up really well. Thank you. If you have any questions, please don't hesitate and feel free to post them in the chat. And at the end, we will try to do our best to address most of them. Okay. So now I will pass to our second speaker. So I would like to invite Dorian Doan. Dorian is a PhD student in the Laboratory of Gastronomic Science at the Jean Blou Agro-Biotech, part of the University of Liège. His academic and professional background is quite diverse and strongly rooted in culinary and scientific expertise. He first trained in food and beverage studies, and then he pursued studies in dietetics and specialized in sport nutrition. And now he's doing his PhD research focused on the development of products based on fresh bacterial biomasses and evaluating the impact of food processing on their physicochemical, nutritional, and sensory characteristics. Dorian, thank you so much for being here with us, and the floor is yours.
Hello, everybody. Thank you, Irma, for the introduction. So I'm going to share my screen. Everything okay?
Yeah.
Thank you. So hello everybody. As Irma said, I'm Dorian Doan, a PhD student at Jean Blou Agro-Biotech. So today I'm going to present you my work. So practically how I want to turn a new protein source, so purple bacteria, and with his name Rhodospirillum rubrum, into a new protein source for new food products, here a milk alternative. So I will start, I just started my second year of thesis, so most of work hasn't been done. It's what I'm going to do for the development of this product. So firstly, I'm going to present you why we use alternative protein rapidly. After that, how I will study purple bacteria as an ingredient, and then the formulation theory and how do I change the final product with the commercial ones. Okay. So quickly, why use new protein alternative? So protein demand is rising with the population growing. The land is no more extensive and is already fully used. Animal proteins have a bigger footprint on the climate, so we need to diversify the protein source to permit and have a more resilient food system. Just quickly. So here with a new source of protein, the purple bacteria, how do we bring it into the human diet? We have many routes possible, but in our lab, we focus on two products, meat alternative, which they present a little bit with Mathieu de Reit, and me, my work is focused on the milk alternatives. And that's why I'm going to develop here. So the real challenge is not the recipe, it's the method. How do you design a food product around an ingredient nobody has formulated before? So everything that follows will be a part of the answer of this question. So for a familiar ingredient, like here I work also on spirulina, you read the literature and build on it. So for example, here spirulina, it's another ingredient, and when you search in the literature, like on Scopus, you have a lot of documents with food products. But if I do the same research with purple bacteria, I only have 54 documents, and of course, almost all of them don't talk about real food product at formulation. It's too little research. And so what we can do is create the literature. So it doesn't exist, so I have to create it, measure, characterize, and document everything. And that's the shift from consuming knowledge to producing it, and it frames my whole approach. So what do I need to know about purple bacteria? So to develop a food product, I need to know the nutritional properties to match a nutritional recommendation of my product. I need also to understand how the proteins and other components works in my ingredient to explain the techno-functional properties of it. So that's the three first. And of course, almost the most important, even if all are important, I need to study the sensorial properties to associate with matching ingredients. And the people who taste them need to appreciate it also. So for the nutritional properties, I focus on the macronutrients, carbs, lipids, and proteins. I will need to match the nutritional values of whole milk because it's my goals in the formulation phase. So formulation phase, I will explain it after. So ashes will give me an idea of the total mineral of the product, and antioxidant capacity is a nutritional interest of purple bacteria because it contains a lot of coenzyme Q10 and other antioxidants, and it's an advantage for the health benefit of the product and the consumer who research new ingredients and healthy ingredients to eat and for the future with sustainable ingredients and everything. Then I will focus on the physico-chemical properties. I need to know the characteristic of my new ingredient because there is nothing in the literature. And it here the biggest part of the work to create new literature. So I will study different things like hydrophobicity, so the affinity of oil water. It's the key for emulsifying and foaming. The zeta potential, so it's the surface charge. It will predict the colloidal stability, really important in for a milk alternative, which is an emulsion. FTIR, for the protein structure and chemical groups. The surface tension, it's the ability to sit and stabilize interface, also for foams and emulsion. The rheology, because it's a flow and viscosity, the texture and mouthfeel of the drink, and the pH, because it's really important for the protein solubility and it affects texture, stability, and taste. So this is a big part of the work, and we need to know everything to understand the next part, which is the techno-functional properties. So when you know the physico-chemical, I'm going to study emulsifying activity, foaming capacity, water solubility index, and swelling power. We could go on other things, but that is my main research for milk alternative. So emulsifying is how well and how long it stabilizes an emulsion. Foam capacity, like when you do a latte, it's an important characteristic, and also for cooking. The water solubility is how the biomass will disperse into the liquid, and swelling power or the water uptake and thickening behavior. After that, I will know the techno-functional properties, but also why they work like that. And that is thanks to the physico-chemical properties I studied before. It's really important to understand how it works and why it works. And the last part, the sensorial properties, where I'm going to study volatile organic compounds that are the molecules behind aroma and of notes. Understanding them enables their pairing with other food products. After, I'm going to do a flash profile with a real human. That's another part of sensorial characteristics. And it's a fast, descriptive sensory method where a panelist ranks samples against references. The taste will be a turning point of the association with other ingredients and food and other aromas if necessary. Well, I know I studied my raw purple bacteria, but does processing change those properties? Like if I want to functionalize them, ultrasounds and PEF can break cell walls, so the protein will be much more disponible and could increase the technofunctional properties or change the sensorial properties. So I'm going to challenge those treatment and do again the technofunctional and sensory test to see if there are differences. But also, if I want to store my ingredient before using it or for the transport, which could be a more longer time, I can spray dry or freeze dry, but it risks to change my technofunctional and sensorial properties also. So I need to see if it's acceptable or not, and if it's worth it or not. So when I will challenge those for processing and see what the difference is and if it's significatively good, not good, or even. Now that I know more about my ingredient, about everything I wanted to do, create new literature about it, what do I do with it? The biggest part is formulation. How to build the product. So for question, what do I want to make? A milk alternative, of course. What does my ingredient already provide? I know it with the previous characterization, the literature I just create. And what do I need to add to improve my ingredient? I can do some research in the literature on what's used for plant-based milk alternative. Also, I need to check what the consumer needs to meet their expectation, nutrition, ingredient sourcing, biological product. It will depend on the population studied and where I want to develop my product. If it's in Europe, America, Asia, it will change a lot. And of course, how I will process my ingredients to have a final product. I can also do some research in the literature on other alternatives already used or on the market and study them. So here, for the ingredients, I'm going to base my values on cow whole milk. So based on the nutritional properties of purple bacteria, I want to complete the macronutrients that lack to match the nutritional values of whole milk of cow. For that, I need to add some good oils because it's better. Some carbs. I want to add probiotics, inulin for the gut health. It's an important part in the European market for the moment. And complete with some calcium and phosphorus and vitamin D for the absorption of calcium. What is already done on plant-based alternative and milk. That's all what I need, but sometimes if the formulation doesn't work like I wanted to have, I will maybe need to add some stabilizer, emulsifier, and aromas to have a more complete formulation, like it's actually the case in plant-based alternative. So after the process, that's a big part. So we have the biomass that is cultivated, harvested, and we have the fresh purple bacteria biomass. I receive the biomass, and I have to dilute it to reach the protein concentration of milk, so about 3.5% of protein, and do or not do a pretreatment, ultrasound or pulse electric field if necessary. Then I'm going to incorporate my ingredients, rapeseed oil, oat syrup, inulin, vitamins and minerals. And I'm going to do an emulsion. So a pre-homogenization plus degassing, because the gas could do troubleshooting in the homogenization. And then after a high pressure homogenization, like it's already done on a plant-based alternative. And we will have like a purple bacteria dairy alternative. But of course, I need to study also pasteurization, UHT or HPP for the conservation treatment, because if you want to sell it, it will need to be preserved, and if we store it at room temperature or fridge, it will depend on the process, on the conservation process. And after we'll have our product. You have under the additives only required stabilizer, aromas, and emulsifier, which are incorporated in the third phase with ingredient incorporation. So how do I check if my formulation is good? By comparing it against existing products across 3 axes: nutritional, functional, and sensorial. It's quite the same as the ingredient. That will be what I'm going to explain. So the benchmark is always with milk and existing milk alternatives, of course. So for my objective, as I said, is whole cow milk. But I use the same ingredients than plant-based alternative. So I compare the 3 of them. And you can see that in plant-based alternative, you have a lot of variability. So I prefer to fix my goal, my objective, my goals on cow's milk, and which is a good product on the market. So I have you can see cow's milk, plant-based. I did the benchmark on like most of different almond milk, soy milk, oat milk, and stuff like that. And there is a lot of variability. So the purple milk alternative will be quite of the same of the cow's milk. And then functional comparison, the 3 main values for my recipe is viscosity and foaming capacity and foaming stability. Because it's really important, foaming capacity and stability for preparing new food and using it as an ingredient, so to cook. And the viscosity is really important also because it will give the information of the taste, or not of the taste, of the palatability and how it feels in the mouth. So I want to be at least as a plant-based alternative and have a good foaming capacity, a good foaming stability. And then the most important part here is the sensorial comparison. For that, we do an affective and preference ranking between cow's whole milk, plant-based alternative, and purple bacteria's milk alternative. So we need more than 60 people, consumers, to validate the test. So to be sure of what they like or not. I will challenge odor, flavor, and off flavor, mouthfeel, and overall liking. Not the color, of course, because it will obviously be different, but it will be a marketing positioning problem, not a sensorial problem. So those information will tell me if my product can be accepted on the market as a new alternative or not, and how I need to position it on the market. That's all for my presentation. Thank you for listening to me. And here I am. If you have questions.
Thank you. Thank you so much, just in time. Thank you, Dorian. So now we are opening a few minutes for questions. If you have any questions, as I said before, please feel free to put them in the chat. If not, I would like to start with one question for Dorothy, please, because you talk a lot about all the factors that we need to take into account for trying to develop a new product. For you, and from your expertise, which one is the most constraining factor sometimes that need to be addressed when developing a new product?
I would say the factor that is not enough addressed when a scientific, I would say, scientific view, like Dorian explained, when you have a new product that it's not known by the consumer, is really to address the sensorial part. Because most of scientists are focused on nutrition, on the impact of the food product, on the way the product is acting on your health and things like that. But then after, they don't realize that this product should go into the mouth of the consumer. And
yes.
It should go more than one time. So it means that you should be very careful with how you construct the finished product, because if there's no market, if there's no consumer acceptation, then after all the research that you've done for years is just useless. So it's not the trickiest things to do, not all the time, but it's still a thing that we don't think about when we develop a new type of product.
Okay, thank you. And Dorian, in the same line, for example, with you are planning to do the sensory test, as it's a new product, I mean, the purple bacteria, I don't know if it's already some regulations behind that or not, but how you will address, do you need, for example, the approval of a ethics committee for doing the sensorial testing or not? Or you just do the sensorial test like that?
That's a good question, because it's a question we ask ourselves. For the profile flash, it's in our lab, so we don't need an ethical committee, because it will be between us and with a paper signed, and we know the risk we take. But if we want to do it on more people, we need to ask how we can do it. Maybe not ethical committee, but just a paper to tell what's the risk, or how what's the risk they're taking by degusting it. But it's a complicated question we are working on. So for the second part, like with a lot of people, yes, we need to ask the ethics committee, but we don't have yet a response.
Yeah, the difficulty is that it's a novel food, but it has already been used as a food complement in some case for cholesterol reduction. And so there's some scientific data about the innocuity of the product, and we have all the analysis to see, if there's something not good inside the product. But the fact is that normally when you do sensorial analysis, you don't have to have ethical committees. Because you're not taking blood samples, for example, you're not directly taking some parameters and some data from the consumer. So you don't have to go through an ethical committee, but still you have some risk that you have to address. And that's the point where there's no real regulation about that, because we are still in a novel food statute. So we're still asking the authorities to see how we can organize that and how it can be safe for the consumer. And so it's still a tricky question, as Dorian said.
Okay. I can imagine that it's not always easier for the new complement and passing from food supplements to food. I think it's quite delicate also. Okay, so I would like to thank you again. I don't see any other question, but please, as Itunga said before, don't hesitate to follow us on the social media. And thank you very much for being with us. Thank you, Dorothy. Thank you, Dorian, for these really, really interesting talks. And I will say bye to everyone and have a nice day. I'm concluding this.
Thank you.
Thank you.
Much.
Bye.
Bye-bye.
Bye.